Data Futurology has three exciting conferences coming up in the second half of the year. We have Data Engineering on the 5th of September in Sydney, followed by Advancing AI on the 6th and 7th of September in Sydney. And then October 24th and 25th, we're going to have our Ops World event in Melbourne. Our conferences cover three main pillars: executive perspectives on leadership and strategy in the space, industry use cases and case studies, and then the third one is advancements in the technologies. Come and find out what's happening in the community, bring your teams along, get everyone together. It's going to be three great events. Hope to see you there.
I'd like to say a big thank you to our sponsors, Talent Insights. Talent Insights are Australia's leading specialist data recruitment business. With offices in Sydney, Melbourne, and Brisbane, they're experts at providing recruitment strategy and building data teams for clients across industries Australia-wide. They provide recruitment solutions for all roles across the data lifecycle, including data engineering, data science, advanced analytics, customer and marketing insights, business intelligence, data product managers, and data governance. They're skilled at finding the best permanent and contract hires for your business needs, as well as statement of work, project-focused data resources. At Talent Insights, relationships matter most. I can say from first-hand experience, Talent Insights are fantastic to work with. Whether you're a business leader within an HR network or a specialist data candidate, Talent Insights should be the first company you turn to for all your data recruitment needs. Find them at talentinsights.com.au.
Hi, this is Felipe Flores. Welcome to Data Futurology. Today, we're going to hear a journey from astrophysicist to head of data science. We're going to hear about industry use cases involving and even some real-time applications. And we're going to discuss where the industry is moving to next and how it's been evolving. For that, I'm super excited to be joined by Conor O'Neill. He's the head of data science at Compare the Market. Conor, great to see you again, mate. How are you going?
Yeah, really well, Felipe. Yeah, great to see you again as well. Obviously caught up recently at the Ops World conference, which was awesome. Yeah, great to be here.
Mate, super excited. Your talk at Ops World was fantastic. That was Ops World Sydney, and where you're doing Ops World in Melbourne later in the year. And mate, I'm super excited to get a chance to pick your brain. Can you start by telling us a bit about your journey, how you went from, astrophysics to head of data science?
Yeah, sure. Yeah. I started, I guess, my journey in the technical fields I did a Bachelor of Physics, a Bachelor of Science with an extended major in physics. And I was lucky enough to do a research program throughout that course. And I would do that at University of Queensland up here in Brisbane, and have a really good but small astro department with some people focusing on cosmology. And I thought that sounds really interesting. I got to get involved in dark energy research. I was able to do that basically from first year of university. So I actually built my first artificial neural network in my first year of uni, just as a way to try to improve predictions of redshifts of galaxies. Which was pretty cool. And anyway, I did a few projects, went over to various places in the world, got to work at a few different telescopes around the world in Chile, as we've spoken about.
Yeah.
As well as in Hawaii, using data from those telescopes, from the Hubble Space Telescope as well.
Wow.
And I think one interesting thing about cosmology is it's essentially statistics on a large scale. So it is, as a requirement, a lot of data collection and analysis. So just by doing that type of work, I was doing a lot of data analysis and programming. I eventually decided not to pursue a PhD and instead went into data science as what seemed like a pretty interesting pivot. And yeah, the rest is history. I got a job as a data scientist at Flight Centre Travel Group originally. Was one of actually the founding members of that data science team, quantitative analyst it was at the time. And yeah, I've worked there for a while, worked at startups. I've done, education, teaching data science courses as a consultant, and done some private consulting, financial modeling, and eventually moved back into the full-time work, joined Compare the Market just at the very start of COVID. So I joined remotely, which is fun. And since then, I've been moved up to the head of data science position. And that's what I do right now.
Amazing. Amazing, mate. And for the people that don't know, can you tell us about the differences between cosmology and astrophysics, and
Sure.
what are the nuances in the space?
Yeah. So the way I think about it is astrophysics is kind of like the physics of objects that are in space. So understanding how galaxies are formed, or black holes, or individual types of things, stellar formation, things like exoplanets. Cosmology is more how did the universe as a whole form, turn out the way it is, where is it going, these types of things. So I mentioned dark energy. That's all about sort of understanding why the universe's expansion rate is accelerating rather than slowing down as you might expect. It's something that's been proven to be the case, and we don't really know why. So yeah, the difference is really the scale, I suppose, would be a good way to think about it.
Amazing. And the data sets that you'd be working on that would be massive, and quite complex.
Yeah.
Yeah. How did you treat that data? How did you either munge it or analyze it when you were in that field? And how is that different to the world that you're analyzing data in now?
Surprisingly, not super different. So I was working mostly with in that field. You kind of divvy up different types of work into the different bands of light that you look at. So light is the way we gather data from various places in the universe, and the wavelength dictates a lot of the types of science you can do and how you can collect that data. And I was using optical wavelengths, and so there is a lot of data in the optical space, but it's not as much as, say, in the radio wave space. So there are some massive projects where I don't know the numbers, but some ridiculous amount of data that gets collected constantly, and it's too big to store, so that you basically have to reduce that massively before you can even get to store it to then do your analysis. But in my case, it wasn't as large as that. So honestly, I can't remember the numbers, but maybe tens to hundreds of thousands of objects. But for each of those, you only have a handful of parameters that you care about. So you can handle that just like any other transactional style data set for that type of thing. There are differences if you're looking at, say, spectroscopy as well. So then you have light spectra. And then we were using sort of specialist tools to analyze that. But no, I was doing a lot of work in Python. And so that translated pretty well. Yeah.
Yeah, awesome. That's great. And can you tell us a little bit about your journey and compare the market so far, and the work that you and the team have done around maturing the capability, the data science capability in the company?
Yeah, it's been a really interesting journey. So when I joined, there had been a couple of data staff members who had worked at the company for a number of years, but it hadn't been its own dedicated function. So not too long prior to me joining, they appointed a chief data officer, who's my boss, and basically appointed him to help to grow the data space. The company identified, this is a strategic thing we need to actually do. So they started hiring people like myself, more data engineers, data architects, and so on. So we did have a lot of really interesting data. There'd already been some experimentation with some machine learning models using some low-code, no-code solutions from other areas of the business, in particular the marketing technology space. So people had sort of built a couple of things there. And when I came in, we wanted to basically first start off by improving some of those that were on the fly, making sure that we were covering off all the governance things that had been missed, and making sure we were able to monitor models properly, retrain them properly. All the documentation was there. The quality of the code and data was good, and we had ways of measuring the business performance and so on. So just establishing core foundational pieces for the projects that were on the fly. But then we sort of moved more into the transformational world and said, okay, so rather than just trying to take projects tactically as they come up or suggest projects, we realized we really needed to invest in changing the way we use data at Compare the Market. So we've been on a transformational journey now for about a year, a bit over a year. That's been really good. So we've been migrating off our legacy on-prem stack to Databricks. Our site is based on AWS, so we've got AWS under the hood there. That's going really well. We've a lot of that is around the process, so getting the right people, but then also establishing a process, because if you just change the tool, you haven't fixed the issues typically. And on the data science side, we've been working on building out more real-time capabilities with a lot more, best practice implemented in the way that we build models, train them, serve them, all of the security and access around that, all of the reviews and automation, the monitoring, and so on. In addition, we've had a digital transformation just broadly. So currently, the data space sits independently from the IT space. And so there's been digital transformation in the IT space as well. We've had a lot more architects join and more senior IT staff. And so we've also started implementing improved operational procedures and DevOps work, and how we structure our internal architectures between services and all of our different APIs that we're building out. So so the current case that we're working on right now, we're close to delivering, is a really interesting one. I think I can go into a little bit if you're interested.
Yeah, that'd be great.
Yeah, so the idea here is to compare the market is essentially a place you can go if you're interested in getting various types of products and you want to find out what might be best for you. So the products that we focus on are typically insurances, as well as things like energy, so your electricity and gas, and more building out the finance space as well, so home loans and things like that. So we've been focusing on this one on the car insurance space. And the way it works is you have to answer a whole bunch of questions in order for us to provide you with quotes for car insurance that are relevant to you, that are actually correct to the information you provided us. And what we were wanting to do was to, a lot of people use us as a research tool and then come back a while later to buy. And we thought, well, I wonder if we can get people to purchase sooner. And I wonder how much, price point might make an impact there. So we've been looking at incentives that we can offer customers at different points in their journey. And so here we wanted to do things in real time on the actual site. The tricky thing is, though, that if you provide a discount to somebody who was going to purchase anyway, then you basically dipped into your own pocket. So you want to increase conversion for people who might have been on the fence without too much of, essentially dipping into your own pocket. So that's the use case from the business side, but it's been really interesting from the technical side as well. We've had analogous data to use from email campaigns that we've, used as a proof of concept to build out that, yes, this was financially a viable product. But in order to actually make this prediction and recommendation of who should we show an offer to, the approach we've taken is to first ingest data when someone's coming through our journey, predict the likelihood that they will purchase, which is something we can do pretty well. And then we thought that alone would be enough to then help to tune who we show an offer to or not. Mm-hmm. We figured at first, maybe it would be people with a high propensity to purchase, because there'll be a portion of those that were really likely to purchase but don't, and maybe the incentive would get them over the fence. But then we thought, well, then we're more likely to dip into our own pocket more. So what about the low group? Maybe we can get some people that aren't likely. So we're reducing risk if we look at the low group. But then there's less likely to gain. And then maybe it's the middle group. And what we realize is it actually doesn't matter what the score is so much, and the likelihood to purchase. We realize that the thing that matters is the incremental conversion you get for that group of people, no matter what propensity they have. And so rather than trying to go through sort of a convoluted A/B test methodology, like a continuous multi-arm banded approach or something like that, we've built our own system to perform those recommendations. The way it acts in practice is it uses that propensity score as essentially a massive dimensionality reduction from all of the various factors that come in, all of the feature store things that we add to that initial payload, reduces all to one number. So we can use that number, put that on a scale, and then essentially just see what groups within, if we were to bucket up that initially as a discrete case, where we are seeing sufficient incremental conversion. So we adjust our traffic accordingly when it looks like, a particular area might be converting at a sufficiently increased rate compared to the control group, then we can increase traffic like that, and we can continue to adjust that and ultimately turn that into a continuous automated process so that we're fairly hands off as long as we have our reporting and alerts off the back of that. Also means it can adjust to changes in customer behavior as well.
That's ace. That is ace. So then, and sorry, what is the kind of like the one metric that you have as featured reduction? That's what you ended up creating.
Yeah, it's funny. I mean, it's actually the prediction, the propensity score itself. So the likelihood that someone will buy. I mean, I think about it as in practice, it's a dimensionality reduction.
Yeah, right.
Many inputs and then one output. And we're using that to then make decisions based on, okay, that's the number we're using for each customer, their score.
Great. That's great. And then you're measuring the increase in conversion versus expected or historical?
Control. So always control, because we are in a seasonal business, both just naturally, there are cycles to when people care about getting their insurance renewed or changing and so on. But also there are, marketing campaigns that might go on that might increase traffic, and there's various types of things. So I'm very much a control group person for the same scenario, but it's always an adjustment, right? Because you don't want your control group to be too large and miss opportunity, but you don't want it to be so small that you don't get sufficient data. So that's where the algorithm behind the recommendation system controls that to optimize basically according to our confidence that we are or are not exceeding the required threshold, and adjust the weighting of the control group accordingly.
Mate, that's ace. That's ace. And it really shows the foundational work that you were mentioning before, the transformational work that you guys have been doing to get to a stage where you have a platform that can deliver this level of experimentation and adjustments in real time. How was that journey of setting up the capability to be able to enable this?
Long and interesting. Yeah, we found a lot of. I mean, it's not that long when I think about certain other transformations. There's been a lot of building the plane while it flies for different areas, all at the same time, independently. So having to coordinate that has been a big task. We had a pretty good idea about what we wanted to do from the data science side from the get-go, but we still learned a lot along the way around sort of adjusting things and certain expectations, as well as, for example, the two-system approach of predict and then recommend was not what we originally thought we were going to be doing. But yeah, so initially we actually thought this would be a pretty straightforward process because there are some similar processes in play, but with the changes in the architecture, a big shift in sort of how we want to internally build products and enhance them. There was a lot of coordination required with the architecture teams, the tech teams, the DevOps teams, the security teams, especially because the Databricks real-time ML endpoint actually doesn't sit within your own environment. It sits on Databricks' environment, which means you have to traverse the internet to do that hop. And there's a few things along the way where you have to consider, and also what will that mean for latency and all these types of things. Not to mention Databricks itself didn't have that ready when we were first going through our ideation phase. So we've actually been working with them pretty closely and getting into private previews early to testing, provide feedback, and so on. There's still a few things that we want to use that aren't ready yet that we've had to build our own versions of, but we'll migrate them when that's appropriate. At the same time, of course, the data engineering function has been onboarding a lot of the data to the sort of more warehouse side of Databricks to improve the modeling in particular. That's, I think, the biggest improvement to what we're doing, the definitions, documentation, and modeling. So we actually have a cohesive data model. So working together with the engineering team as well as the business teams to just get the data right in the first place has been a big job too. So we're actually still finalizing some of the data at this moment. Hopefully by the time this goes live, that's all done and we're more or less ready to go live with the product. So.
Amazing. Yeah, that is phenomenal. And how was it working across the organization with all those different areas in order to get kind of this cohesive or a cohesive movement on the use case?
Yeah, really interesting. So the way we obviously data transformations and digital transformations are a big investment in both time and money and resources. So we went through a big process on how we wanted to approach that, in the first place. And one of the ways we did that was to say, okay, what's the business value we're going to deliver out the back of this? We know there's going to be a continuation of many projects we can build for every section of data that from the business that we onboard, that we model, and that we go through. But in order to make have some sugar for the pill, we wanted to lock in a few business use cases that the business identified as high value. So this was one of those. So we workshopped a few things with them, and this was one of the ones that came out the back of that. So then it was just a process of trying to ensure that we understood what was being required from the business team, went through quite a number of workshops to say, okay, from a data science view, what could we do that would help with this space? But we did actually face a challenge where because this isn't a lot of the time, with data science projects, they're kind of considered, okay, they're in the data science camp. The data scientists will be building it. They'll be delivering the project. And I've been really pushing to change that mindset to sort of more of the product-driven development, where the data science work is a component of the product. So this is a new feature to, for example, our car insurance product. And so it needs to enhance that product. And that requires, obviously, a number of different teams. Our commercial teams for what are the enhancements they want. Obviously, data science who build the core functionality to enable it. But also our IT teams to make sure that it's integrated and works well as our customer experience to make sure those look good, the customer journey makes sense. So a lot of coordination there, and that's been something as a business that we've been really trying to improve because so far historically IT and the business teams worked pretty closely together, but as I mentioned, data was off to the side a bit. So we've been making lots of headway in bringing those areas closer together, not just at an individual project level, but also as an organization to make sure. Actually yesterday we went through our FY24 planning, and a big part of that was getting all of these different groups coordinated, discussing the improved processes that we're doing as an organization to make sure dependencies are managed well. It's a really difficult thing to get right, especially as in the data space, not everyone's needed at the same time. You might have your business analysts right at the start, engineers for different types of parts of your pipeline sometime later. Your modelers need to get in there at some point. Your data scientists need to help to create the solution design, but have to wait till that data is ready to actually build the thing. And you can't test stuff until the new APIs are developed. And then after that, you want to ingest the data from those APIs to build out your reporting as well. So yeah, lots of coordination, lots of learnings. We're not in a perfect place yet, but for sure in a lot better place than we were 12 months ago in that coordination, and I think it will just get better.
That's great. That's excellent. And I really like that you have been deliberate about kind of getting people on the field and off the field at the right times, and definitely having the data scientists in the design is something that I maybe I'm biased, but it's something that I haven't seen enough of. I think it's something that's very necessary, and how did you get that up and running in your case? Was that part of an expectation, or did you have to convince people?
Yeah, so we started with the design because it was sort of put forward as, here's a data transformation project. We're going to start with tar for various reasons. Here's the prioritized use cases, and these are sort of data science and BI use cases. So, and some of them are also just integration use cases that then we optimize in a downstream platform. So that meant that the onus on the solution design starts with the data scientists for those, because that was the process. But what we realized later is, that doesn't really align from a delivery perspective with how we need to coordinate to build things. So we were pretty comfortable on the data science side about, what we were going to do and when we were going to do it, all our dependencies. But what wasn't so clear is the exact architecture holistically. So I actually learned a lot trying to do that. I hadn't really done a lot of solution architecting previously. So yeah, I tried my hand in that, which was good. We have now an architecture governance council that I'm a part of that reviews these types of things. And we've been increasing our architecture group so that we have more people with the full architecture experience to build out systems, well principled, and ensure, we were very into infrastructure as code, deploying everything repeatedly in a repeatable manner. Later, basically, it was just a matter of trying to coordinate a lot. There was a lot of back and forth, a lot of revision, for sure. Also, I have to give massive shout out to the main data scientist in my team who's been working on the development of this. So Ben Croker, he's been amazing, and he's gone above and beyond from his role. We all know data scientists have a ill-defined remit at the best of times, can be many different things. And in this case, Ben has joined our our API committee, and has, been speccing out the APIs, which has been great because then it means the developers and IT can test against that. What's the payload we're expecting? To get into the weeds on a lot of the details around how we deploy so that everything works well. There's a lot of funky things still with some of the way things work, because, for example, Databricks' main focus has been traditionally Spark-based, so that's batch building, which isn't quite there for real time. So there's some interesting things that come along, some of the APIs that you have to use, that require certain functionality that you might build differently if you're doing a custom job. I think really having good people to work through some of these projects and some of these problems has been absolutely critical.
Amazing. That's awesome, man. And you've been now head of data science for a couple of years, and so I wanted to ask you about the transition from data scientist to senior to then head of. How have you found that journey, and what do you see as some of the gaps that people should be thinking about filling before jumping to a head of position?
Yeah, it's been interesting. I would say it depends what you want to do, really. The way it sort of happened for me is that I tend to just think about things from an optimizing perspective generally. So I'm not really interested in building models that sit on the shelf. Because it's, it's optimizing if you are using it, but you're not using it. What's the end-to-end processes there? And even, is this the right project to be working on? Like, what's the core business problem that's underlying a particular project that's trying to be addressed? Is this the right project to address that? Also, are there lower hanging fruit to try to address that? So I've actually extended my remit to include a lot of the BI space as well, just because there's a lot we can do there to help out, in particular, the sort of commercial side of the business in terms of just data availability and ease of use. So for me, the transition was basically identifying, well, we could keep building models, we could keep trying to deploy them tactically, get something out the door. And that has had success. We've had a lot of financial success from that. But at some point you realize if we keep moving in this way, we're going to have a heck of a lot of legacy that is going to be really difficult to maintain, might not have been the best solution in the first place. And so balancing that out has just let me go, well, let's step one level above. What are the problems that the business is trying to solve? What are the best ways to do that? So what that's meant for me is initially I was still doing a certain degree of the building, but as time has gone on, it's less and less. And it's much more like lately we talked about the coordination. So that's been a big part of my latest challenge that I've been working through is actually delivering these projects on in this business that is going through a lot of change. So basically for me, it's all about in a head of role, being responsible for getting business value at the end of the day. So the data scientist might be responsible for building a great model that achieves the goals it's meant to do. And they're not necessarily responsible for the end-to-end project success. Whereas for me, I go, great, if you've done that as a data scientist, you've done your job well. Now I need to make sure that gets used in the right way with the business. So we haven't missed anything, that we're not going to run into something down the road that is an absolute deal breaker for the project, for example. And that, we can anticipate issues ahead of time. We're making sure that all the best practices are there, that, once we go live, we're ready with all of our monitoring. We know how we're performing straight away. We can redeploy immediately. We know how we're going to do that. And all of these things that you don't necessarily need to concern yourself with as a data scientist.
Right. So true. So true. So many things in that answer that I love. So good. Yeah. Around the front end, working on the right things. What are we going to tackle? I think those are great discussions to be having. It also sounds like you look for patterns in what's required from the projects that are of higher business value. So to say, kind of like, how can we design something that can enable multiple the delivery of multiple projects at once? So I think that's great.
And reusable work as well. So reusable work. So the use case I described before, right? We have one use case in mind, but we're making that propensity score either way. So we can reuse that component for many other types of use cases as well. So I think, that's an important point, as well as also what not to work on. So working with, my senior leadership team and the various commercial teams to give that input on, are we ready for that? Is it actually the best project to work on? And finding those groups of people who are going to be good to work with. They get it, helping to drive that data maturity sometimes means delivering cool projects that other people then start to take interest in, rather than trying to force it for people who may not be as interested to begin with. So finding those champions through the business and working together with them.
Exactly. I love that. That is excellent. And then it sounds like you got a really good focus on delivery of the projects, and that you're measuring the success of the projects by the adoption, by the impact that's created by having the models in production, and with everything that means, like model registry, being able to have model redeployment, as you mentioned. You might have kind of like a champion challenger approaches there as through different model iterations, but that the model is in active use to make decisions for people. How was that? Let's ask you a little bit about that kind of last mile of getting it in front of users, getting the models in front of users. How was that, either from a delivery perspective or build perspective, working from the business? How was that last mile of the project?
So in terms of getting in front of users, actually our approach is, my personal approach is, it depends on the maturity of the business and what they're ready for. For me at CTM with machine learning projects, the preferred solutions that make sense for supervised learning type projects are ones that interact with other systems, because then everything has to be pretty precisely defined. So as opposed to, for example, having a prediction that then a person reviews, that means you have to upskill those people and make sure that they're understanding everything at a much deeper level. Whereas if it's all systems, you don't have to do that so much. Obviously, people have to understand what the impact is and how these will integrate. But basically, for us, we're using, like I said, Databricks. So we can build our models on Databricks. We can deploy them on Databricks. We have MLflow there as the sort of model registry. And we can, control what we serve behind the endpoints that we specify. We can put together the API spec in our API documentation tool. And that means that actually the users that we're putting in front of are the IT staff. So they're already technical. They don't need to understand the details behind the model. They just need to know what's going in and what's coming out. What are the error modes that are there? And then that's, again, we can document that. So we can say, this field is going to be null some of the time. That's okay. And we can handle, if we need to impute that or not on our side. But these other fields are required. They have to be there. That is an expectation, and that would be enforced in the APIs. So in terms of the users, do you mean sort of the business users at the end of all of it, or?
No, I was thinking the customers. But I really like the fact that you focused, on in this case on the technical users and having that agreed interface with them. That then you can change what you need to change in the model. You can adapt. You can create new models, and that the interface is the same. So then the downstream predictions can be presented where they need to go to be put in front of the customer, and that's great. But yeah, I was thinking of the user being the end customer, but I can see that the technical teams are part of essentially the consumer of in a way, right?
Yeah, that's true. It's a really good point. I guess there's maybe several consumers or users that we need to think about. So one is the other people that we need to work with to deliver the project. So IT, like I mentioned, as sort of the literal consumer of the endpoints that we serve. Then there's the customer, like you said, who are going to see the outcome of the recommendation. And I should say that there are business logic that exists in the pipeline that can overrule recommendations that we put forward. So we have that in place for scenarios where ultimately the commercial team, the business team gets to make those calls. But again, they're not making those calls on the fly. They set up the rules and then we implement the rules. From the customer facing. So on the data science side, we mostly are interested in making sure that things don't logically conflict, so that we're not, for example, measuring things incorrectly in terms of, offer redemptions, let's say, and that, we're using the right identification to make sure that a customer is the person we think they are, or that, if we're reserving an offer, are we doing it to the right person? Under what circumstances do we need to do that? The customer experience, though, is handled more by our CX team. So they think about everything from the design of what that would look like on our results page through to the entire customer experience from, start to end, end being sort of any length of time in the future. So how does this coordinate with our email campaigns? Are there conflicts there? Are there things that are going to be confusing as a customer to see, oh, I saw this now, but there's a random element because we have control groups to the office. So if I come back, will I see that again? All of these things have been thought through, primarily the commercial and the CX team together, and then they get the technical input as well. So, hey guys, if we wanted to go down this route, what would that mean? And we can give our input there, as well as also our assessment on, do we think it would cause a financial impact? Just the analysis side of certain types of considerations. But yes, we do have a team that thinks about that deeply to make sure that the customer is having a good time and aren't confused by anything.
Yeah. Yeah, amazing. And I really like that you mentioned, and it's quite quite clear that you guys take a product based approach to what you deliver as an organization. But additionally, you're taking a product based approach into the machine learning models that you create. So it becomes kind of an internal product to be consumed within the organization through in this case through the API delivery.
Mm-hmm.
What are some I guess tips or guidance that you could give people around thinking of creating ML as a product to be consumed internally? How does that change either the planning, the delivery, the infrastructure required? Any tips on that front, ML as a product?
Yeah. So I mean, we're fairly early in that journey, but certainly the way I feel at the moment is I'm definitely a fan of the product-driven development for the sole purpose that it coordinates all the different groups together, to make sure that everyone's focused on delivering the same thing, reduces the amount of conflicting projects that might come in from the side to take away one group of resources to work on something else and make delivery a bit more confusing. So I think alignment to a product definitely works. But in the solution design phase, I think so both in the prioritization of what projects you work on, and in the solution design, I think it's really important to think about not just solving for now, but solving for the future. So in this case, we have a couple of scenarios where we've deliberately said these components are, well, one, this project is being chosen because it has an immediate value it can deliver, but it has components we'll be able to reuse for different things in the future. So two examples of that are, on the ML side, I mentioned the prediction model. So that can be used for a lot of different things. So we have call centers and we currently use prediction models in there as well. And we can continue to enhance that. We can improve a lot of things in that space, as well as, we're looking at a lot more modes of how we interact with our customers. So this becomes an endpoint that sits behind an API. That means that from a development point of view, they don't actually need to care that much about the system itself that we've exposed. They only need to care about that interface API, and that's all spec'd out. So future use cases can go, oh, well, there's a documentation. As long as I pass a call to that, I'm going to get back a certain response. And in our case, with this use case, the thing that's calling it will take that into account and then pass it on to the second model because that's that use case. But it doesn't interfere with other use cases that might want to call the same, one of those models, the predicted model. So we sort of segment up the different functionalities in that way to make those components reusable for other use cases. And some of them we already know, and some of them we will discover in the future. And I think that design approach means that you allow for not having to redo things every time. It also means when you're building, like, what is your training set, and what are you considering as success? Your target feature, for example. Do you want to say, oh, someone that bought ever after that date, or do you have a time window? Do you need to deploy a few different versions of this for different types of use cases? And we can think about all of these options. But yeah, like I mentioned, even in the ideation stage, I think this is important because maybe the first use case has a certain amount of value, but there's 20 other use cases off the back that you can think of that are going to add a lot. So that means on a strategic level, you could go, well, maybe this is like a medium-sized value for the first use case, and there might be a higher value project, but that higher value project might be a one-off, and there might be other considerations around it. How complex is it? And if you go, well, we deliver this one, we get a medium value, and we enable these other ones to be delivered pretty quickly after that because they can reuse components, then I think you get a lot more extra wins along the way. The other component I mentioned that we did this for this project is an API specifically for offers, so that we can, in the future, right now we're looking at one type of offer. In the financial implications of the different offers are going to impact how we do the recommendation, for example. It doesn't influence the score, so we can reuse that again and again, change the recommendation later for different types of offers. Ultimately, we want to get to an approach where we come up with what is the best offer for an individual, if any. for any scenario, and how do we want to deliver that? And we can picture those use cases and make sure that we build components where there might not be very much extra work to make it easier in the future to extend the capabilities. So that's how I think about it.
Ace, mate. That is so great. That is so good. I know we're running out of time. We're basically over time, but I want to ask you one last question, if that's all right. I want to ask you about your thoughts on how the industry is evolving, how it's changing, things that you see coming down the pipe, or some of the changes that you've seen recently, where as an industry we've increased our maturity, and that you're excited about where that is going. Any thoughts on next steps for the industry?
Yeah, it's been interesting. So obviously, like, if you follow the hype train, it's gone, data science for a while, and then people doing large projects where they couldn't deliver properly because that coordination wasn't understood. Identifying data engineers are key to this, both for getting the data in the first place, modeling it well, but also serving infrastructure and all the rest of it. So that has been, a big push recently. I've had people wonder, is data science going down because there's a big push of data engineering? Maybe those projects aren't there. I actually don't think that's the case. I think it's just standard maturing, where, there's the value is still there, but I think the industry is realizing what it takes to deliver properly. And so once everyone's hired all the engineers, I think you can expect to see a lot more data science projects being delivered successfully as well. I do think, and then obviously all the ops changes, has been a big thing recently. But I think, ops has been one where, the process isn't super complicated and the tools keep getting better and better. So I think that's just getting more and more automated, and also as a pattern. So that means once you do it well once, you can reuse it. There's a lot of things where you can put in that pattern formulation to reuse, but it's going to continue to be critical. But I think just like many other things, it will become fairly out of the box for a lot of technologies. Depends how you do it. If you build your own stack, it's different. But and I suppose that's another thing. There's been a lot of debate recently around, hey, are microservices the best solution? Discussion of maybe bringing back the monolith app. I won't get into that debate, but for sure there's complexity around building your own end-to-end machine learning infrastructure that has all the components all plugged in together. That adds different types of complexities, even though it also allows for other types of flexibilities. I think one really interesting thing is obviously the generative AI space. I don't know yet what that will mean for. I've tended to avoid deep learning use cases of various types because I haven't found that the business value has been there for the anticipated work required. There's not as high ROI for, I think, most businesses. But I do think that there's been a change with what's happening at the moment in the text-to-text generative AI space, ChatGPT and others, in that it wouldn't surprise me if we're soon to find a complete shift in how you can build customized recommendation models or predictive models based on interacting with a language model. So discussing with it and providing data to it and saying, what comes next. That would be a really big shift, I think, in how we approach data science, how we approach machine learning for building predictive models. I still think that, foundational skills are critical. So I don't consider data science as just machine learning. I think you really need to understand the maths and statistics and programming to get the best out of a business scenario. And of course, the soft skills and understanding the business and communicating well, I think are always going to remain critical. I think potentially, though, the door might start opening even further than the low-code solutions to other types of business areas. And you might find that there will be the role shift into more of like data science as a service type scenarios, where it's more like integrating other applications, or being a steward for the business users who are maybe using data science-like tools directly, like in a no-code solution where, you know, business users who might not understand what's going on behind the scenes can still quickly create things that are useful right now, but then you might need someone with a bit more technical expertise to make sure there's nothing funky going on, and you know, the measurement makes sense and so on. So yeah, I think the core skills are always going to be critical. I think there's still a lot of businesses that will have custom use cases of building ML, like what we're doing at the moment. But I do think the generative space is a watch this space for core data science work, in addition to obviously all the new use cases that it opens the door for. So yeah, interesting times.
Mate, I love it. I love it. Thank you. That is brilliant. That is brilliant, mate. Thank you so much for taking the time to walk us through your background, your experience, your super exciting real-time projects, and then your thoughts about how what it takes to become a head of, and the type of how that widens the area of concern that people have, and how to have more impact in the organization. And then talking about what's coming up next with the development of, you know, ops and the generative AI coming in hot off the press. So, mate, thank you so much for your time. That was excellent.
Thanks, Felipe. It was great to chat with you.
Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.